Today we shall be considering the topic multiple question and answers on atomic physics part 1. Before we continue, let us consider the energy level diagram for hydrogen. This is the figure. The diagram you can see from my left is the quantum numbers, and from my right you can see the energies in terms of electron volts. Vertical arrows you are seeing represents the 4 lowest energy transition for each of the spectral lines. The colored arrows in the Balmer series indicates that the series results in visible light. That's what I'm trying to say. Here you have the n. So here you have n equals to 1, n equals to 2, n equals to 3, and all of that. These are the quantum numbers, and on my right is the different forms of level of energy in terms of electron volts. You see the vertical lines, but these ones are colored. The colored ones fall under Balmer series, so this is the visible region. The Lyman series is the UV region, the ultraviolet, the region of ultraviolet light, and the Paschen series is the region of infrared. So those ones are not colored as well. Okay, so let's continue. Just consider hydrogen atom transition to different levels of energy. The Lyman series. If you look at that figure, you see that the vertical lines all terminated at n equals to 1. Those ones that ended at n equals to 1, that's the transition to n equals to 1 level, is assumed to be in the region of the ultraviolet ray, UV region. So for the Balmer series, the vertical lines terminate at n equals to 2. That is the visible region. For the Paschen series, the vertical lines terminate at n equals to 3 level, which is infrared region. For the bracket series, the vertical lines terminate at n equals to 4, which is the infrared region. In this case, you can just say far infrared region, but it's still infrared region. The same thing with the Pfund series. The vertical lines terminate at n equals to 5, which is the infrared region as well. Let us consider the following examples or objective questions. This one says, what causes the emission of spectral lines in an atomic spectrum? What causes the emission of spectral lines in an atomic spectrum? A. Nuclear splitting. B. Electron absorption of energy. C. Electron transition between energy levels. D. Photon fusion. The correct option to that question is C. Electron transition between energy level. When electron move from one energy level to the other energy level, you simply see that emission takes place. So the question said, what causes the emission of spectral lines in an atomic spectrum? The correct option is C. This one says, which of the following series lie in the visible region of the hydrogen spectrum? Which of the following series lie in the visible region of the hydrogen spectrum? A. Lyman series, B. Balmer series, C. Paschen series, D. Bracket series. So I would like you to think about the answer, although we've discussed that before. Okay, so the correct option is the Balmer series. Okay, next question. In the hydrogen atom, the Lyman series corresponds to transition where electrons fall to which energy level? In the hydrogen atom, the Lyman series corresponds to transition where electrons fall to which energy level? A. N equals to 2, B. N equals to 3, C. N equals to 1, D. N equals to 4. For Lyman series, we have N equals to 1. Option C is the correct option. Which of the following, let me shift this downward, okay, there's nothing there. Which of the electromagnetic spectrum does the Paschen series fall into? Which region of the electromagnetic spectrum does the Paschen series fall into? Ultraviolet region, visible light region, infrared region, and the X-ray. The correct option is the infrared region, as we have discussed. Okay, this one says, who proposed the model that explained the hydrogen spectrum successfully using energy levels? Who proposed the model that explained the hydrogen spectrum successfully using energy levels? A. J.J. Thomson, B. Ernest Rutherford, C. Niels Bohr, and D. Schrödinger. The correct option is C. One says, which of the following best describes a continuous spectrum? Which of the following best describes a continuous spectrum? A. Spectrum that contains only specific wavelength of light. B. A spectrum formed by excited atoms emitting photon. C. A spectrum with all visible wavelengths blending smoothly without gaps. D. A spectrum caused by electrons jumping to higher energy level. Which of the following best describes a continuous spectrum? The correct option is C. A spectrum with all visible wavelengths blending smoothly without gaps. So for a continuous spectrum, there is no gap in between them. Okay. According to the Bohr's model of the atom, how is an emission spectrum produced? According to Bohr's atomic model, how is an emission spectrum produced? A. When electron absorbs energy and jumps to a higher orbit. B. When electrons move randomly in the nucleus. C. When electrons fall from a higher to a lower energy level, releasing photons. D. When protons and neutrons collide. Correct option is C. When electrons fall from a higher to a lower energy level, and of course you know that photons are being released. According to Bohr's model of the atom, how is an emission spectrum produced? So the option there is C. And lastly, we'll look at this. How is an absorption spectrum formed according to the Bohr's theory? When a hot gas emits light at specific wavelength. B. When electrons in atoms absorb certain energies from incoming white light. C. When a dense object emits all visible wavelengths of light. D. When electrons fall back to the nucleus and release energy. The correct option here is B. When electrons in atoms absorb certain energies from incoming white light. When those electrons absorb this energy, they get excited and jump to the next energy level. So the question said, how is an absorption spectrum formed according to the Bohr's theory? When electrons in an atom absorb certain energies from incoming white light. Okay, so that's how far we can go for today's class. I believe you enjoyed the lecture. Thank you for watching Supreme Online Lectures. Have a wonderful day. Please, I would like you to do me a favor by clicking on the subscribe button and also share to others. Have a wonderful day.